Good morning, everyone. Today I will discuss about Analytic Geometry 1. Under Analytic Geometry 1 are the topics on lines and circle. In geometry, we have discussed geometrical objects such as, for example, lines, shapes such as the ellipse, heart, and 3D objects such as here we have cylinder. These geometrical objects can be represented by algebraic expressions, such as, for example, our line can be written in algebra as y equals mx plus b. The ellipse may be written as this formula. Even this heart can be written in this formula or in this equation. The cylinder is simply an equation of a circle in 3D space. So the conversion of geometric figures to algebraic expression is called the analytic geometry, or the conversion of algebraic expression to its equivalent geometric forms is also analytic geometry. Thanks to René Descartes, who introduced to us the tool to convert geometric figures into algebraic forms, or from algebraic forms to its geometric figures. So analytic geometry is actually the marriage between the two branches in mathematics, the geometry and the algebra. So let's discuss now the Cartesian coordinate system. Cartesian, which is taken from the name of its um, inventor, René Descartes. Assuming we have a point on the Cartesian coordinate system, which is located horizontally at 4, here, and located vertically at 3, then this point can be located on the address 4, 3. This address is called coordinate. The first number in the coordinate is called the abscissa, and the last number is called the ordinate. The intersection between the x and the y axis, or the intersection of our axis, is called the origin. Okay, assuming that we have 2 points on the Cartesian coordinate system, then we can determine the distance between the 2 points. Assuming we have a point 1 located at 1, 1 and another point 5, 4. Now, there is always a direct distance between these 2 points. The direct distance is called the distance between the 2 points. Okay, how do we determine the distance between the 2 points? We can determine the projection of this line on the horizontal, and we know that this distance is equal to, well, 1, 2, 3, 4. It is because we subtract the total distance from the origin, which is 5, by the distance from here up to the first point, or we have 5 minus 1, or the difference on the x's of the points. The x here is 5, the x here is also 1, so we have a net of 4. Now the vertical projection of this line is also the difference in the y's of the endpoints. We have 4 here, we have 1 here, so we'll have 3. Or we have 4 minus 1. Okay, what we see now is a triangle, a right triangle. And we can use the principle or the formula of Pythagoras, which states that we can always determine the length of the third side, which is the hypotenuse, for a right triangle. So we'll use the Pythagorean formula to compute for the distance. In this case, the distance is equal to 5 because 4 square plus 3 square is 25, and the square root of 25 is 5. So our formula for the distance is determine the net between the x's, square it. In this case, the net is 4 between the two x's. And then determine the net between the two y's. In this case is 3. And then square it. This is the distance formula. Okay. What is the distance between A and B? Okay, so this is now our formula, assuming that this is our small x or big X, and this is our small x. So we can now substitute here. Our big X is 4, this 1, and the small x is -2. So we have minus -2 squared. So this is the net between the two x's. And we have also the net between the two y's, -3. And we have also here 0. So the net is -3 less 0. Okay, so extract the square root. We have square root of 36 plus 9, this is square root of 45. Or we can rewrite this in a simpler form, a 3 square root of 5. The point x1 is 2 square root of 5 units from 2, 3. Find x. So this is our formula to determine the distance, the net on the x's, the net on the y. Now, if this is our small x, small y, and this is our big X, big Y, then we can substitute them in the equation. Our distance is 2 square root of 5. Our big X is 2. Our small x is x squared plus our big Y is 3. Our small y is 1. Now, you can enter this or you can input this in your calculator and use the shift solve function of the calculator to determine the value of x. Unfortunately, in my calculator, the result is no solution. So I proceed to squaring both sides and arrive at this equation. Square 2 is 4, square root of 5 is 5. 4 times 5 is 20. And we have this expression here. Now I try again calculating the equation using shift solve and then arrive -2 and -6. Take note that you need to perform shift solve operation twice in order to arrive to these two results. Be careful to change the initial value provided by the calculator to arrive to another value. Okay, so we can also instead of using shift solve, there's another method to use that is much faster than shift solve. Assuming we want to determine the root of this equation, we want to determine the value of x here. If we use shift solve function of the calculator, it may take time for the calculator to iterate the equation. So what I did is I rearranged the equation, I moved this on the other side, and now we'll have 2 square root of 5 minus now square root of 2 minus x squared plus 2 squared, and then then it is now equal to 0. So you can now enter the expression, this expression except the 0 in your calculator. So after entering 2 square root of 5 minus square root of 2 minus x squared plus 2 squared without equal 0, press calc. The calculator will ask for the value of x to be substituted. Now we'll check if it is an A, meaning we want to try or test if A is the correct answer. So if x is -3, then we will evaluate this expression. So substituting -3 using calc function of the calculator, press equal, then the result is -0.91. Since the result is -0.91, meaning letter A is not the correct answer because what we desired is a result of 0, because according to the equation, when the correct value for x is substituted here, the result must be equal to 0. Now, since negative 3 is or does not satisfy the equation, then proceed to another choice. So let's proceed to letter C. Now, press calc again and then enter negative 2 in your calculator. Press equal, the result is 0. So, meaning negative 2 is the solution of this equation. Now let's try again. If 6 here works on the same equation, so we press calc again, and then now we enter 6, and then we press equal, and then we get 0, meaning the answer is letter C. Assuming I have a point 2, 4, and the point 0, 0, or the origin. This is our line segment, and we wish to determine the midpoint of the line segment. Now, the length from 0 to 2 is 2. This is the projection of our line segment on the x-axis. Its midpoint is here. This is the average of 0 and 2. Because 0 and 2 is 2 and its average is 1. Now the projection on the y-axis is the segment. And the midpoint of 4 and the midpoint of this segment is located at 2. Which is actually the average of 4 and 0. So the computation for the midpoint is easier. We simply calculate the average between the two x's, the average of 4, in the x here, the average of 2 and 0. This is 2 and this is 0. So we'll have 2. And for the y is to determine the average of the two y's. The y here is 4, the y here is 0. So we'll have 4 plus 0 is 4. Or to determine the abscissa of the midpoint, we determine the average of the x's. And then to determine the ordinate of the midpoint, we determine the average of the ordinates. Or in formula, the midpoint is the average of the two x's and the average of the two y's. Okay, the points x, y, and 2, 3 has a midpoint at the origin. Determine the x and the y. Okay, so our midpoint formula says that it is the average of the x's and the average of the y's. The midpoint is located at the origin, meaning its x is 0 and y is 0. So, meaning the average of x's is 1, which is x, and 2, its average is 0 because the midpoint is at 0 or at the origin. So we can determine that x is negative 2. Now, the average of the y's here, y over 2. We have y here is 3 and the other y here is y. So the average of y and 3 is equal to 0. Then we can determine y is equal to negative 3. Okay, the line segment connecting x, 6, and 9, y, is bisected by the point 7, 3. Find the values of x and y. Now we have 2 points. It is bisected. We have first point x6, the other point is 9y, and it is bisected by a point, meaning bisection is division of segment into two equal parts, and the point at the midpoint or at the mid of the segment is 7, 3. Now we use the same formula to determine the value of x. 7 is the abscissa of the midpoint. It means that 7 is the average of the x's. Our x here is x and our x here is 9. And the average of that x's is equal to 7 according to the statement. Now x may be determined by using shift solve. Now, to determine the value of y, 3 is the average of the two y's, y and 6. Now 6 plus y over 2 is equal to 3. Then we can determine the value of y by using shift solve. The value of x is 5, while the value of y is equal to 0. Okay, so assuming that we have here a general point, big X, big Y, and then we have another point here, small x, small y. Now, this segment will be divided into some proportions. In our case of midpoint, this segment is divided into two equal parts. This point is the midpoint. The ratio of these two segments are in 1:1. And we can determine that the midpoint of this point is simply the average of the two x's and the average of the two y's. Actually, this is maybe written as this form where we can write 1, 1 here, where 1 is the ratio of the two segments. 1 here, we have also 1 here. And the denominator is the sum of the proportions of the segments. The same with the ordinate. We have 1, 1, and we have also the sum of the proportions of the two segments. Now, assuming that the point is not located at the mid of the segment, so let's say somewhere here, then the segments is now divided into two ratios or into segments in a ratio of small r to big R. Then we can write that the midpoint of this point, so let's say the point is P, we write here the denominator is the sum of the two proportions, small r plus big R, small r plus big R. While the coefficients of our x's and the coefficient of our y's will depend on the location of the point. For example, if this is the big X, then we have the small r here. Meaning, if our segment is located here, it is paired with the point on the other side. Meaning, we'll use this r this r must be paired with the point big X, big Y. That is why we have here small r. Its pair is the big X and the big Y. On the other hand, the big R here is paired on the point on the other side. That is, our big R is paired with a small x and the small y. Okay, let us illustrate that principle here. The segment from -4 to -2 is extended 3 times its own length. Find the terminal point. Here is our original segment. It is extended 3 times. First extension, second, and third extension. And we have the terminal point. So let's call it big X, big X, big Y. Now, if this is the ends of the final segments, then we can use the mid or the formula for the partition of the segment. Now, this one may be represented by a segment 1, while the other segment may be represented by 3, meaning the segment is divided in a ratio of 1:3. So our r, small r is 1, our big R is 3. So we now use this formula to determine the value. Here, the value of our point is at 2 minus 2. And this is equal to this expression here. First, we write the proportions 1 here, 3 here, 1, 3, and so with the y. And then we pair our r with their corresponding points. For 1, because 1 is located on this side, then it is paired by the point on the other side. So that is why our 1 and this 1 must be paired with the points on the other side. So for the x, This is 1. Its pair must be the x. So its pair is x. And on the y, its pair is the big Y. And now for the 3, this segment must be paired with a point on the other side. For the 3 here, its pair, this is 3, its pair is -1, and its pair on the y is 4. So we can now rewrite the expression. This axis has an average of, has a point somewhere on its line equal to 2. So we have this one, while the y has this point -2. So we have y plus 3 times 4 is 12. So we have -2, which is this point, is equal to y plus 12 over 1 plus 3. So y is equal to -20. Determine the coordinates of the point, which is 3/5 of the way from the point to -5 to the point -3, 5. So here we don't necessarily need to draw the segment in the Cartesian plane. So as long as we have first point and we have the second point, regardless of the orientation, we can always form the segment. Now according to the problem, from 2, -5 to -3, 5, there is a point somewhere which is located exactly 3/5 of the way. Meaning, first we divide the segment into 5 in order to have 5/5. Now, we only want to count 3/5. This is one of the fifth, 2/5, and 3/5, meaning our point is located here. Let's say its name is x0, y0. We use the formula to determine the location of this point. Now we can say that the proportion of these segments is now in 3:2. So using the same method, we'll have our XO is, we write the ratios of the segments. We have 3, we have 2, and then we have 3 plus 2 here. The same for Y. And then for the X, for 3, it is paired by the points on the other side. So the value here must be -3. For 2, it is paired by the points on the other side. So it must be 2. So that's why we have here 2. Again, here, this is 3. So this is paired by the y on the other side, which is 5. And for our 2, it is paired by the y, which is -5 on the other side. So we can now determine the value of that point. Okay, let's now proceed to determining the equation of the line. Assuming we have 2 points 1, 1 and 3, 5. There is only exactly one line that can pass through these points. So what is the equation of this line? In geometry, we can draw the line, but in algebra, how do we express this equation or this curve in algebraic expression? In order to do that, we will determine the property of this line. Observe that we can determine the proportion of the rise to the run of this line. The rise is the net between these 2 points on the vertical, and the run is the net between these 2 points on the horizontal. The ratio is 4/2 is equal to 2 because 4 divided by 2 is 2. We can also determine the same proportion of the rise and run somewhere here. At this point, the rise is 2. This is 1, 2, while the run is 1. And the ratio is 2 divided by 1 is the same 2. by similar triangles, because all of the triangles that is formed by the rise of a run along this line are similar. Meaning if it is located on some point x, y, then the rise could be the net between this point and this point. The net on the y's is y minus 1, and the net on the x's is x minus 1. Meaning, if we divide this vertical distance by this horizontal distance, we might be able to calculate 2 by similar triangles principle. Okay, so the original ratio based on our 2 points is 4:2, or is equal to 4 divided by 2 is equal to 2. Meaning, 4 here is the net between the two y's of the endpoints, which is 5 and 1 is 4, and the net on the two x's of our endpoints, which is 3 and 1. This ratio is the same as the ratio of y minus 1, which is the net on the y's, over the net on the x's of any of the point x, y on the curve or on the line. So this is now the equation of, or the equation defining the line. This may be written, or our final expression may be written as this way, in a general form of the equation. To make this line, or to make this equation more meaningful, we write this in this form. Okay. Observe that the slope of this line, which is the ratio of the rise to the run, is equal to 2. It is actually the coefficient of our x here. Meaning this line, if this curve is written in this form, y is equal to some x minus some constant or plus some constant, then we can extract the information right away. The coefficient of the x is the slope of the line. The negative 1 here must be something on this line. The negative 1 here is actually the intercept on the y-axis. Meaning, if we set x to 0, the value is equal to negative 1. Now, observe that when the x is 0, the value of y here is negative 1. Okay, so this equation here is the general form for the equation of the line. This is the equation of the line based on the 2 points. Sometimes this is called, or most of the time, this is called the 2-point form equation of the line. This is our first form of the equation of the line. Okay, if the slope of the line is known, meaning this expression, then we can write the expression here. We replace this by m, and then we copy the same equation or expression above. This is the second form equation of the line, and we call it the slope point form. We have the slope, and we have here the point on the line. Now, if we know that the line intersects the y-axis, meaning when x is equal to 0, we have a defined value for y. That is, if x is 0, so let's say the value of y is b, then this will be another form of the equation of the line. This is called the y-intercept slope form, or the slope and y-intercept form. When we rewrite this expression, we'll get this expression above. But I write it this way in order to maintain the meaning of these equations. And we have the fourth, which is called the intercept form equation of the line. If it is known that the line intersects at x-axis at A and intersects the y-axis at B, then we'll have this equation. Assuming we have 3 points on the plane that are not collinear, we can always draw a triangle using these points. And the area of this triangle can be computed using the determinant formula. Simply arrange the points x1, y1, followed by a constant 1, x2, y2, followed by a constant 1, x3, y3, followed by the constant 1. And then multiply it by a half, then what we will get is the area of that triangle. Observe that if the third point lies on the same line, meaning the area of this triangle is now reduced to 0, then what we have now is a line. So we can write the equation of this line in this form, the area form equation of the line. So meaning we use this definition of the area, and since the area formed by this equation or by this expression is equal to 0, then we'll have this expression for the equation of the line in this form, the area form equation of the line. The line passes through 1, -3, and -4, 2. What is the equation of the line? A, y minus 4 equals x. B, y equals -x minus 2. Okay, our formula is a two-point form equation of the line. Assuming that this is our x1 and that is our x2, now we can substitute for the value of y2, y1. Our y2 is 2, our y1 is -3. This is 2, and y1 is -3. And for our x1 is 1, and our x2 is -4. So we can rewrite this expression, and we have the final equation for the equation of the line. Now observe that this line passes through the points 1, -3, and -4, 2. Meaning, if the answer to this question is the option A, then this line must pass through the points 1, -3, and -4, 2. Meaning, we can always check without knowing the equation of the two-point form using the reverse method. Assuming we want to determine if A is the correct answer, then we need to determine whether this point or whether this line passes through this point and that point. Okay, let's try for this point. If y is equal to -3, x is 1, meaning -3, and this is 1. So we substitute -3, we substitute 1. On the left side, we have -7. On the right side, we have 1. The statement is not true, meaning it is not A, because the line does not pass through that point. Now let's proceed to letter B. For letter B, let's try y -3 and x 1. So we have -3, -1, and evaluate the expression. This is -1, -2 is also -3. This is true, meaning B probably is the correct answer. But we need to check that with the other points because this point or this line must also pass through this point. So we substitute now 2, which is here, and for our x is -4. So we have this is 2 and this is -4, and negative of -4 is 4 minus 2 is 2, and this is correct, meaning the answer is B because this line passes through the 2 points. What is the x-intercept of the line passing through 1, 4 and 4, 1? Okay, what is the form of equation of the line to use? Here we have 2 points provided. This line passes through these 2 points, meaning we'll use the 2-point form equation of the line. This is our point 1, that is our point 2. So we can write this expression using that point. Now, since we are looking for the x-intercept, we do not need to write this expression in the form of y or in the form of slope-intercept form. This expression is sufficient. When the statement says that we want to determine the x-intercept, meaning the curve intersects the x-axis, meaning at that point the y is equal to 0, meaning we simply set y to 0, and then compute for the x at that location. Then from here we can determine that our x is equal to 5. What is the equation of the line that passes through 4, 0 and is parallel to the line x minus y minus 2 is equal to 0? The problem provides us with a point and a hint of a slope. Thus, we can use the point slope form equation of the line. This is the point slope form equation of our line. Now, first, we will determine what is the slope because we already have the point x1, y1 here. The slope may be determined from the equation of that line. In order to determine the equation or to determine the slope of this line, we rearrange this equation to a slope-intercept form. We write the y on the left side and the rest of the values on the right. So we have x here and we have plus 2 here. It must be plus 2. Now from here, the coefficient of x represents the slope of the line, and that is equal to 1. Since our line that passes through 4, 0 is parallel to this line, meaning when it is parallel to that line, meaning its slope is also equal to the slope of this line. And the slope of this line is 1, meaning our original line that passes to 4 to 0 must have also the same slope. So our m is equal to 1, and our point is 0, its y is 0, and its x is 4. So we can rewrite this expression this way. So this is the equation of that line. Or we can rewrite this depending on the choices. Given three vertices of a triangle whose coordinates are A, B, and C, find the area of the triangle. Okay, so we can use, let's plot these points here. This is A, and this is our B, and this is our C. Now we have a triangle formed by these points. We can now determine the area using the determinant method. So we write this one as our x1, y1, x1, y1, x1, y1, and a constant 1, x2, y2, x2, y2. So we have x2, y2, and the constant 1. And lastly, we have the x3, y3, which is 5 minus 3. And then multiply it by 1/2. So this will be our matrix. So in this method, I will not introduce the method to compute the determinant using the long method. Instead, I will use the function of the calculator because we will be discussing matrix in detail in our advanced math topic. So after determining the determinant of this matrix, we multiply it by 2 and then we'll get the area. Okay, this is the method. Enter this expression in your calculator under matrix mode. So we have 1, 1, 1, 3 minus 3, 1, 5 minus 3, 1. In your calculator, press mode, and then this will appear. We want the matrix mode, so we select number 6. So press number 6. When you select number 6, this will be the option. Which matrix you want to use, A, B, or C? So let's say we want to use matrix A. All of these matrices are the matrix available in your calculator. So we select matrix A by pressing 1. And then it will ask you for the dimension of the matrix. This is a 3 by 3 matrix. So 1, 2, 3, this is 1, 2, 3. So we select 1 to select the matrix. And then we enter the values of this matrix. After entering the value of the matrix, press AC to clear the screen. Take note that we are still on the matrix mode. When we are on the matrix mode, we can always access the functions of the matrix. Take note, when you want to access the functions of the matrix, you should not press the mode button again. Pressing the mode button again will reset the data on your matrix. So we will not go to the mode to access the function of the matrix because we are already on the matrix mode. To view the functions available for matrix, we proceed to the matrix function or here. This is the menu for the matrix or to determine more functions for matrix when we are on the matrix mode. So to access these functions, since this is color yellow, so we'll press shift first because shift is color yellow. So shift and then press 4. This is what we get. Now, because we already have matrix A, what we need to determine is its determinant. We have here the depth for determinant. Press 7. When we press 7, this appears on the screen of your calculator, and then we now want to put matrix A as our argument. Again, do not press mode because it will reset the matrix data. Access the matrix function through Shift 4 and then select matrix A, number 3, and then close parenthesis. This is the result for our determinant. So the determinant of matrix A is equal to 4. So dividing it by, 8. So dividing it by 2, we have 4. So the area bounded by these sides is equal to 4. In a Cartesian coordinates, the coordinates of a quadrilateral are 1, 1, 0, 8, 4, 5, and negative 3, 4. What is the area? Okay, let's say this is our points A, B, C, and D. And this is our A, 1, 1. Our B is 0, 8. Our C is 4, 5. Now, our D is negative 3, 4. If we write these points in that order, what we form is not a polygon. Okay, to determine the area of this polygon, we cannot use the determinant method because when we attempt to use the determinant method, the matrix that we will have here is not a square matrix. Not a square because the columns is 3 while the rows is 4. In order for a matrix to have a determinant, it must have an equal number of rows as the columns. So instead, in order to determine the area of this polygon, I will use another method. I will use this method. So let's say we write the coordinates of these points. Make sure that the points first must arrange in order. So assuming this is our first point, have a coordinate of 1, 1. So we have 1, 1. And the next point is the next to that point, not B, because the B is not next to that point. So let's say our C. Our C is 4, 5, so we write 4, 5 here. Followed by B, which is 0, 8. That's why we have 0, 8 here. And lastly, followed by D, which is negative 3, 4. We have negative 3, 4 here. Now we close this by going back to A, which is coordinate of 1, 1. So we have 1, 1 here. Okay, the 1, 1 here is not a constant. It is the coordinate of the first point. So in order to determine the area, we need to calculate this way. First, multiply in that direction, and then add all of these products. We have 34. Next, record this value, and then we multiply in that direction, and then record the sum of these products. We have this value. Now we subtract negative 16 from 34. We'll have 34 minus negative 16, and then we divide it by 2, and then we'll have the value of the area. Okay, assuming we have this point, originally we have this point of the equation 2x minus y minus 1 equals 0, which is written as y equals 2x minus 1 in slope-intercept form. And assuming that we have a point here with coordinate negative 1, 4, and we wish to determine the distance of this point to this line, or the shortest distance of this point to this line. Assuming that the general equation of our line is this one, ax plus by plus c is equal to 0, then we can determine the distance from a point to a line using this formula, where xo, yo is the coordinate of that point. Okay, so for example, this line and that point. So we can determine the distance by first determine the coefficients of the x and the y. The coefficients of the x is 2. The coefficient of the y is negative 1. So we have 2, and the coefficient of y is negative 1. And we have here the constant. The constant is located on the left of the equation. So whatever is the sign of the constant here, it must be its final sign on the numerator. Our c here is negative 1, so we have here negative 1. Our xo, yo is negative 1 and 4, so we have negative 1, and we have here 4. Our a, which is the coefficients of the x and the y, a and b, is 2 and negative 1. So we can determine the distance to be equal to this value. Find the distance from the line to the point. So this is the equation of our line. This is our a, our b is negative 3, and our c is 5. So we use this equation now. So we have 4, and this is negative 3, and this is 5. And our point is 2 and 1. So we have 2 and 1. Our a is 4, our b is negative 3. So we'll have 10 over square root of 25. Square root of 25 is 5. So 10 divided by 5 is equal to 2. Okay, so given the two parallel lines are considered to be parallel, or lines are parallel if the slope are equal. So if one line is ax plus by plus c1 is equal to 0, then the equation of the other line can be written in this form, ax plus by plus c2. Meaning, if the two lines are parallel, then they can always be expressed having the same coefficients in x and y. Okay, the distance between these two lines is determined using this formula. Okay, assuming we have these two lines, 3x plus 5y plus 30 is equal to 0, and we have 9x plus 15y plus 120 is equal to 0. As you can observe, they do not have the same coefficients on x and y, but they can be written on such a way that their coefficients are equal if they are parallel. First, we need to determine if they are parallel. To determine if the two lines are parallel, first determine the ratio of their x's and the ratio of their y's. If the ratio of their coefficient on x and y are equal, then the lines are parallel. Since these two lines are parallel, meaning we can express their coefficients to be equal, I can do this by dividing 9 by 3 to get 3. Dividing 15 by 3, we get 5. So meaning we can have this expression to be equal to this equation, 3x plus 5y plus 40. So we now have two parallel lines. So to determine the distance between these two lines, we have 30 and 40 divided by 3 plus 5 squared. Find the distance between the lines 3x plus y minus 12 equals 0 and 3x plus y minus 4 equals 0. Okay, it is obvious that these two lines are parallel because the coefficients are already equal. Now the result is negative 5.06. Since we are referring to distance and distance will always be positive, then we get the absolute value of the distance, which is 5.06. Okay, if the two lines are not parallel, then these lines must intersect at some angle. Assuming we have two lines having slopes m1 and m2, then what is the angle between these two lines? The angle between the two lines can be determined using this method. First, we determine the angle of the first line. The angle of the first line can be determined from its slope. If the slope is m1, meaning we can always have a right triangle having these proportions of m2 on this side and 1 on this side. Because m1 divided by 1 is equal to m1 and this is the slope of this triangle, the same as the slope of that line. We can determine the angle here using the trigonometric formula or trigonometric function using the tangent function. We know that the tangent of theta 1 is the ratio of the opposite to the adjacent, or we have tangent theta 1 is equal to the slope of the first line. By the same reasoning, we can determine that the angle theta 2 may be determined by the slope of the line M2. Meaning, if we want to determine the angle theta 1, we need to perform opposite operation for tangent theta 1, and that is arctangent. So theta 1 is arctan of M1, therefore theta 2 is also arctan of M2. So meaning we can determine the difference in the angle to determine the angle between them by subtracting the angle theta 1 from theta 2. Okay, if lines are perpendicular, then we'll have this one. The angle of intersection between these two lines is 90 degrees. The relation between their slope is this. The slope of the first line is opposite reciprocal of the second line. Okay, assuming that the first line has this equation and the second line has this equation, in order for these two lines to be perpendicular, we need first to determine the slope of the first line and the slope of the second line. And then check whether the slope of the first line is opposite reciprocal of the other. But there is another way to determine whether these two lines are perpendicular using the coefficients of the x and the y. If the product of the coefficients of x's plus the product of the coefficients of the y's is equal to 0, then the lines are perpendicular to each other. Example, if we have the line x plus 2y plus 2 is 0, and the other is negative 4x plus 2y plus 8 is equal to 0, we can always determine that its slope is equal to negative half. Well, transfer the x on the other side, transfer the 2 on the other side, divide both sides by 2, we get negative half for the coefficient of the x. The same way, we can also determine the slope of m of this line. Transfer this on the other side, that will become 4x divided by 2, that becomes 2, so we have 2. We can check that negative half is the opposite reciprocal of 2, meaning these two lines are perpendicular. Or we can also use the direct method by using the coefficients of this line. The coefficient of x is 1. The coefficient of x here is negative 4. We multiply them. 1 times negative 4. The coefficients of y here is 2 and this is also 2. So we multiply together, we have 2 times 2. Adding them together, the result is 0, then these lines are perpendicular. Find the angle from the line 2x plus y minus 8 equal to 0 to the line x plus 3y plus 4 equals 0. Okay, first determine the slope of this line. We rewrite this equation in this form. In the slope-intercept form, in such a way we can determine easily the slope of that line. The slope of this line is negative 2. Now, we write also this equation in the slope-intercept form, and we found that the slope of this line is negative third. Now we can determine that this line has a slope of negative 2, and the other line has a slope of negative third. So we can determine that the angle between them is the difference in their arctan. So we have the angle to be equal to 45 degrees. Okay, for the circle. This is an example of a circle with center at the origin. If the radius is r, then we can write the equation of the circle to be equal to x squared plus y squared is equal to r squared. The equation of the circle is based on the definition that it is a locus of points equidistant from a fixed center. That definition is the Pythagorean formula. That is why the formula for the circle is actually a Pythagorean formula. If the radius of the circle is 1, we refer to that circle as a unit circle. If the radius of the circle is 0, meaning we cannot see any circle anymore, but there is a circle, the radius is just 0. The circle is said to be a point circle. Now, if the center of the circle is other than the origin, so let's say at the hk, then we can write the equation of the circle this way. X minus 8 squared plus y minus k squared equals 0. When the h and k is located on the origin, this is equal to 0. That's why we have this equation. Okay, assuming we have a circle whose center of abscissa or whose abscissa of the center is at 2 and whose ordinate is at 3 and the radius is equal to 2, then we can draw the circle this way. The center is at 2, 3, and the radius is equal to 2. Now, the circle can be readily drawn if it is always given in its standard form. This is the standard form of the equation of the circle. When we say standard, the equation gives right away the center of the circle and its radius. But most of the time, the equation of the circle is not given in its standard form. It is given in the general form, where this expression is expanded and the other is expanded. Aside from that, these values are not arranged in such a way that we can recognize easily the equation, whether it is a circle or what kind of conic. So, if the given equation looks this way, how can we determine the center and the radius of the circle? Take note that this equation is just the same as this equation above, meaning the center of the circle, by looking at this equation, is not readily available. I mean, not readily visible. But we can reverse the operation in order to determine the center of the circle and its radius. In order to do that, we need to group them together. Group all of the x's and group all of the y's. Place the constant on the right side. And then we complete the square of this expression. By completing the square, we mean that we divide the coefficient of the x by 2 and then we square it. If we divide 4 by 2, we get 2. If we square 2, we get 4. We add 4 here. Now on the other side, in order to complete the square of this y, we divide this by 2. 6 divided 2 is 3. Square 3 is 9. So we have 9 here. It is always positive here because whatever the sign of the coefficients here, be it negative or positive, since it is squared, the result is always positive. So we always add positive. We always add positive here. Since we added 4 and 9 on the right, on the left side, in order to make the equation balanced, we must also add them to the other side. So this is our final expression. We can rewrite them this way. We can rewrite this one because this is a perfect square. This is 4 divided 2 is 2, and we retain the sign. And this is also 6 divided 3 as 2 is 3 square, and we retain the sign. On the other side, we have this is 9 minus 9 is 0. We have already here 4, and the square root of 4 is 2, so we express 4 as 2 square. Now we can see that the radius is r, which is 2, and the center is at 2, 3. So the operation to determine the center is, will now generalize them here. To determine the center of the circle, we simply locate the coefficients of the x or the y. Our x is here, our y is here. Not the y square, not the x square. Only the linear or the coefficients of the linear x and the coefficient of the linear y. So whatever is the coefficient of the x or the y, we simply divide it by 2 to determine the center hk. Now to determine the radius, observe here that we have the constant. We add, this is the square of the h, this is the square of the k, 2 square and 3 square. So we have this formula. Okay, find the equation of the circle whose center is at 3, negative 5 and whose radius is 4. We have the choices here, and this is our method. First, we have the standard form of the equation of the circle. The center are provided, or the coordinate of the center is provided. We have 3 and negative 5. Then we can expand this to get this expression. Okay, just in case you are too lazy to compute the expansion of this expression, we can always determine the answer because we have the equations here. If we have an equation and we have points, then we can use that point as the test value for the equation. Let us test whether A is the correct answer, meaning whether A is that circle. According to the statement, it has a center at 3, negative 4, negative 5, and a radius of 4. Meaning, I can always find a point on the circle. But the point given here is the center, which is not on the circle. We cannot use 3, negative 5 as the test value for the curve because this point does not lie on the curve. We must always use points that lie in the curve as the test value. This point is on the curve. The coordinate of this point, its x must be the same 3 and its y is 4 units below negative 5 because the radius is 4. So it must be negative 9. This point lies on the curve, so meaning we can use this value as the test, or we can use that point as the test point. Now, enter this equation because we are checking whether A is the correct answer. Enter that expression in your calculator. We have x squared plus y squared minus 6x plus 10y plus 10. And then press calc because you want to determine if x is equal to 3 and y is negative 9, whether its value is equal to 0. So x, we use 3, y, we use negative 9. The result is 0, so meaning this point is indeed on the circle, meaning letter A could be the correct answer. In order to establish our solution using this method, we substitute another point in the circle, the point somewhere here. If the result is still 0, then That is the correct answer. What is the center of the curve x squared plus y squared minus 2x minus 4y minus 31 is equal to 0? In order to determine the center or the coordinate of the center of our circle, because the curve is a circle, how can we identify that the curve is a circle in the first place? We can identify whether the curve is a circle first. Identify that the coefficient of the square x squared and y squared are the same. In this case is 1 and 1. They must have the same sign. If it is negative, it must be also negative. Okay, since this is a circle, then we can use our formula to determine the center of the circle, the HK. First, we'll determine the center or the abscissa of the center. First, identify the coefficient of the x. So, we'll use this formula, negative of negative of the coefficient of the x divided by 2. The coefficient of the x is negative 2. We divide it by 2, we'll have 1. Now, to determine the k, we identify the coefficient of the y, which is negative 4. So, negative of the coefficient of y divided 2 is 2. Now, if you wish to determine the radius of the circle, we'll use this formula, the c plus h squared plus k squared. Our c in this case, it must be moved on the right side because that was our formula for c, is 31. So we'll have 31 plus the h squared. H is 1 square, k squared is 2 square. So we'll have r is equal to 6. Find the value of k for which the equation x squared plus y squared plus 4x minus 2y minus k is equal to 0 represents a point circle. Now, when we say that the circle is a point circle, it means that its radius is equal to 0. First, let's identify the center in order for us to determine the radius. The center or the abscissa of the center is equal to this formula. The coefficient of x is 4. We have 4 that might divide 2 and is equal to negative 2. Next, for the k, we'll have negative 2 divided 2 is equal to 1. Now we can determine the radius using the formula for the c plus h squared plus k squared. Our radius is 0. Our c is equal to k because when negative k is moved to the right, it becomes positive. So we have k plus our h is equal to negative 2 and our k is 1. The only variable here is k, so we can solve for k because negative